One more law, and this one has its own twist. Consider sitting on a small cart with wheels next to a brick wall. You push on the wall with your feet. Which way do you go and why? You're exerting a force on the wall, which doesn't move as it's built into the ground and there's a great deal of friction and cement holding it in place. That explains why the wall isn't moving in response to your force. And you know that an object at rest, you, won't move without a net external force. You've exerted a force on the wall, but why are you moving? The answer is the wall is pushing back on you. It doesn't look like it's doing anything, and we haven't covered this yet, but recall from your earlier science courses what makes up atoms. Negatively charged electrons orbit a nucleus. The wall's electrons are being pushed by the electrons in your shoe, and like charges repel. This will be covered in the electric charge portion of this course. So the wall's electrons are pushing you back, and since you're not cemented into the ground, you accelerate as described by Newton's second law. The third law states whenever one object exerts a force on a second object, the second object exerts an equal force on the first object in the opposite direction. The two objects form an action-reaction pair. Since both forces are simultaneous, the designation of either as the action force is somewhat arbitrary. It is important to note that the forces act on different objects. Don't make the mistake of applying these two forces to the same object, or it would seem that nothing could ever move. You can write these forces as the force of object 1 on 2 is equal to the negative of the force on object 2 on 1. They're equal, but they're opposite. So you can say that if we have a book lying on a table, the book pushes down on the table, and the table pushes up on the book. That would be an action-reaction pair.